Two quantified statements have the same logical meaning if they have the same truth value regardless of the value of the predicates for the elements in the domain. So for example, we'll consider a domain consisting of the set of people invited to a party. We'll let P of x represent that x came to the party, and S of x represent that x was sick. So the statement everyone was not sick is logically equivalent to, for all x, the negation of S of x. These two have the same truth values regardless of who was invited to the party and whether they were sick. So for an example, we have this table that gives a set of people who could have been invited to the party and possible values for S of x and P of x. So for the group of people in the domain, we have the statement someone was sick and came to the party. And this is false, since if we look in the sick row, there's only one person who is sick and they did not come to the party. However, there exists an x such that S of x or P of x is true. Since we have, for instance, Joe. He wasn't sick, but he did come to the party. And this is an or statement, so we only need one of them. We also have Theodore, who was sick and didn't come to the party, as well as Gertrude, so all three of these people do satisfy the statement. Therefore, someone was sick and came to the party, and there exists an x such that S of x or P of x are not logically equivalent. And this is because we found that there exists an x such that S of x or P of x is true. However, someone was sick and came to the party was false. So let's do another example. In this problem, the domain will be the members of a board of directors for a company who are considering a proposal for that company. We're going to let R of x mean person x read the proposal, V of x, person x voted in favor of the proposal. So we're going to translate each sentence into the equivalent logical expression. Everyone who read the proposal voted in favor of it. So for all x, if R of x, then V of x. So this may not immediately look like an if-then statement, but it is. It's basically saying if the person read the proposal, then they voted in favor of it. Do another one. Someone who did not read the proposal voted in favor of it. So for the last one, you'll notice it said everyone, which indicated a for all. Someone indicates that there exists. So there exists an x such that the negation of R of x and V of x. So they did not read the proposal, so we have the negation of R. And they also voted in favor, so and V of x. One last example. Someone did not read the proposal, and someone voted in favor of it. So once again, the someone indicates a there exist. There exists an x such that the negation of R of x. So this covers the first part of the statement. Someone did not read the proposal. We then have the and. Someone voted in favor of it. So and there exists an x such that V of x. We do need two quantifiers here, because the person who did not read the proposal may not be the same person who voted in favor of it. These may be two different people.